All right, class, welcome back to the binomial theorem. We're going to look at binomial expansion first. If we are asked to expand or come up with a product, if you will, of this binomial x plus y to the fourth power, just the same as x plus y times the quantity x plus y times x plus y. If you take a product, this special product, it's a plus b times a plus b, or in this case x and y. So the first term squared plus a product of the two, which is xy, then we double it, we get 2xy, plus the last one squared. So these two binomials equate to this trinomial. These two binomials equate to this trinomial. Now I've taken each value in the first trinomial and color-coded them. X squared times each value. X squared times x squared is x to the fourth. Distributive property x squared times 2xy, x squared times y squared. And we'll take the middle term, 2xy, multiply it times all three, and you get these three blue terms. Then we'll take the last term, which is y squared, times all three again. You get the three red terms. So I've got a total of 9 terms. I'm looking for similar or like terms. And when I combine the x cubed y's, there's a group of 2 and 2, so that takes a group of 4 total, and you can strike those out. X squared y squares, there is 3 terms. This one, which is 1, 4 of these, and another one, making a total of 6. You can strike those out then. Then we're looking for something else different. So we've got x, y cubes. There's 2 and 2 of those, or a total of 4, and then the straggler, y to the fourth at the end, or the bookends, if you will. So this is binomial expansion. We can use the binomial theorem as well to solve for this. So you can kind of look at it there in your text if you like. It's not for the faint of heart. So I'm going to show you the way I've always done it. So you have 2 values, or 2 variables, if you will, 2 terms. They don't always have to be variables, but this one is. So we've got 2 terms, and you're going to write them as x to the fourth, y to the 0. So this is the greatest that we know we'll end up with, x to the fourth. This would be the least. This is plus, we're putting plus. We're going to leave a space for the coefficient, if you will. We're going to do x cubed, y to the first, plus, leave a space for the coefficient. Notice the x's are decreasing, 4, 3, x squared, which is 2. The y's are increasing from 0 to 1 to 2, plus, and we need a coefficient. The x's are decreasing. The y exponent is increasing. Place for the coefficient. Then, don't forget, x to the 0, y to the fourth. Now, from the binomial theorem, you can either do combinations, okay? You can either do combinations for the coefficients, or you can take them from rows in Pascal's triangles. So we want to look at the row 4, if you will. We should have 5 terms in row 4. 1, 2, 3, 4, 5, or 5 coefficients. And the coefficients are this understood 1, 4, 6, 4, and 1. We'll clean it up just a little bit. Anything to the 0 power is 1. 1 times x to the fourth is x to the fourth. Plus, then we have a 4x cubed y, plus 6x squared y squares, plus 4x y cubed, plus, then we've got 1 times 1, x to the 0 is 1, so 1 times y to the fourth, or plus y to the fourth power. So, using binomial expansion, Pascal's triangle for coefficients of our binomial multiplied 4 times, we get this 5-termed polynomial. All right, got a couple more examples for you. We'll get to them in a second.